Hey guys, welcome back from hopefully a great Thanksgiving that saw you guys staying safe. So good to have you back here. Um, I had a great Thanksgiving break. I made broccoli casserole for the first time and it was amazing. I'm really actually proud of myself because I like to think I'm an okay cook and baker, but sometimes I screw up. So I'm glad I got it right this time. But speaking of getting it right, day 8. I'm going to go ahead and prep you guys. This is going to be a long day. So I'm going to try and split this up as best I can to kind of help you guys get this in bite-sized pieces. So I'm going to split into sections. Also, I want to keep in mind that as of now, guys, we got our test this Thursday. So keep that in mind. We got a test coming up this Thursday. I believe that is the 3rd of December. So keep that in mind as we jump into our new day here. Let's go day 8. So once again, just like the rest of this chapter, sticking with triangles. This time though, we're talking about special segments, and there's going to be 4 in particular that we look at. Medians, altitudes, perpendicular bisectors, and then angle bisectors. Now we've heard of a couple of these. Perpendicular bisector and angle bisector, we know that has to do with cutting things in half. Medians and altitudes, you may not have heard of as much. So let's kind of see what these are all about here. So we'll start off with angle bisector. That is definitely one we've seen. And here's what an angle bisector is. You guys have seen this before. It is a line segment array. In this case, you would say line segment AD, starting at the vertex, boom, that's where it starts, and cuts an angle into 2 equal parts. Bada boom, bada bam. So that's what we got going on here. So we would say AD is an angle bisector. Now, to go along with the angle bisector of a triangle, we have, of course, a good old angle bisector theorem. So, good old proof may come into play at some point. So if a point is on the bisector of an angle, boom, point D, then the point is equidistant from the sides. So what that means is this point is equidistant from the sides of the angles. So there's angle B and angle C. This point is equidistant to C as it is to B. In other words, these 2 sides are congruent. So we would say AD, our bisector, it would be our bisector, and we would say BD equals DC. All right, and then now let's put this into practice a little bit here. Let's see how this works whenever we actually have a problem. So XP is an angle bisector. Okay, that means XP is splitting this angle and this angle into equal pieces. We know those are equal. Now, angle YXZ, so YXZ, this whole angle is 4x plus 5. That would be this whole angle. And angle 1 is going to be 5x minus 2. So angle 1 going to be, this is the measure of angle 2. My bad. My bad. So, sorry, angle 2 is 4x plus 5. Whoopsie. And angle 1 is 5x minus 2. And some of you guys are already way ahead of me. They want us to find YXZ. So in other words, we need to find the whole. So what do? Well, if these angles are congruent because they're being bisected, take 4x plus 5, set it equal to 5x minus 2. And I'm going to give you guys a few seconds. Go ahead and see if you can solve this for me. Solve for x. But remember, we're not done once we find x. So go ahead. So I worked it out. Subtract 4x over, add 2 over, x equals 7. And I said, okay, so now we need to find out what the whole angle is. So let's find out what one piece is. I'm going to take that 7, plug it in. So 5 times 7 minus 2, that is 35 minus 2. We know angle 1 and angle 2 are both 33 degrees. And so if they're both 33 degrees, just take 33, multiply it by 2, and we now know that angle YXZ is going to equal 66 degrees. So hopefully you guys felt pretty good about that. This bisected this angle, which means they're the same, set them equal. We work through it. Once you find what x is, you can plug it back in, and then double that angle to find the whole. So on to the next page. We're halfway through video 1, guys. We got this. So we're on to page 2. And here's what I'd like you guys to try for me. I'm going to see if you guys can handle this problem right here. Try part 1 and try part 2 for me. We're dealing with an angle bisector. So we know LO is going to make that angle and that angle the same. And we also know then that means that because it goes through point O, O to M is going to be the same thing as O to P. And so I'm going to let you guys see what we can do with this information as we work through part 1 and part 2. Okay, so because this is an angle bisector, we know that this side and this side are going to be congruent. So if we need to find out what x is to find these missing sides, we then know that 6x is going to equal 3x plus 12. Subtract 3x over, and then divide. You get 3x, divide 12 by 3. X equals 4. We want to know what segment OP is. So we plug 4 into x. 3 times 4 is 12. 12 plus 12 means OP is going to be 24 units. And then this last segment is as easy as it sounds. We're told MLO is 32. Well, because LO is an angle bisector, we know then that OLP is going to be 32. And then what is MLP, M to L to P? Oh, that's this whole angle. Double it, 64 degrees. So that one was not too bad. And so guys, let's finish talking about bisectors by getting away from angle bisectors and talking about, I'm going to switch up the color here. Let's talk about perpendicular bisectors. So that word perpendicular, let's remind us here. Perpendicular means what? It means forms right angles. It means that two lines hit perfectly enough to form right angles. So a line segment or a ray that is perpendicular to the opposite side of the midpoint of that side. So, okay, perpendicular, so we know hits against the opposite side of the midpoints, boom, of that side. So it bisects, splitting up equal, so we have equal halves, equal half, and it creates our right angle. So the bisector part comes from there, and the perpendicular part comes in right there. We can see that there, and we can see it doesn't even have to go through a vertex. Like, it doesn't have to go through Z. It can just cut right down the middle here. But check it out. On this one, it does come right down the middle. And we then know that, okay, point C is on this angle bisector. That means that not only would from point D to point A be the same and point D to point B be the same, but check it out. That means point A to C and point B to C is the same. Because C is also on this bisector. So C to A is the same as C to B. And there's our right angle for perpendicular. So this is kind of an interesting problem. And it involves something called the perpendicular bisector theorem. You guys are noticing that we're having a lot of theorems to go along with our concepts here. So this theorem says that if a point is on the perpendicular bisector of a segment, kind of like C, then it is equidistant from the endpoints of the segment. So C to A, C to B. We can see that there. So when is we know equidistant? If you're not sure what that means, that just means a point is the same distance from two different objects. So kind of like how C is the same distance from A and to B. That's all equidistant means. So a little real-world application. I'm going to let you guys try this one for me. Go ahead and give it a shot. See what you think here. I'll give you a second to read this. You can pause the video. Well, we know that we're told the monkey bars are located midway between the slide and tether ball. So we know this side and this side are congruent. But also, if we were to draw a perpendicular bisector, so a straight vertical line that hits right here, creates a right angle, in fact, two right angles, and it hits at the midway point, we know then that from the slide to the foursquare would be congruent, and the foursquare to the tether ball, those would be equidistant. And so when it says which of the following are equidistant from the slide and tether ball, not only are the monkey bars, it wouldn't be the kickball, it wouldn't be the hopscotch, it's going to be foursquare. All right, and then the last one I'm going to do with you guys in the video, before I let you try one, and then we wrap up video one, is let's look at example number one here. This is actually a pretty quick one if you recognize that line MP is a perpendicular bisector. That then means immediately this side and this side got to be the same. So if this piece is 3, boom, that piece is 3. That also means point M is on our bisector just like point P was. So from N to M, M to O, the same. So if that's 7, that's 7. So they ask us to find NP. Well, we just did. NP is 3. And find the perimeter. Well, that's going to be as easy for MNO, the whole triangle, that's going to be as easy as 7 plus 7 plus 3 plus 3. And our perimeter ends up being, when you add all that up, 14 plus 3 plus 3, 20 units. Not too bad, right? So far, so good, hopefully. I'm going to let you guys try number 2, and then we will wrap up video 1 by checking it. So go ahead, guys, give me your best shot on example number 2. All right, let's see how you guys did. So we know this point is on the angle bisector, or the perpendicular bisector, which means that this side and this side are congruent. By the way, if these two sides are congruent, we know we got an isosceles triangle. Just a fun little reminder there. Two sides are the same. So you set those sides equal, add 6, divide by 7, x equals 5. And so guys, I will see you over in video number 2.